Okay, so in this video, we're going to talk about three formulas that we're going to use for word problems in topic 2. The first one is growth and decay, so exponential growth and decay. Formula for this, 2, 1 plus or minus r times t. Okay, so let's talk about the parts here. So this a is my final amount. Okay, the p stands for my initial amount. The r stands for rate. And then the t stands for time. Okay, so that's growth and decay. For compound interest, we have A is equal to P1 plus R T. Okay, and then we have very similar parts. So this A is again my final amount. This P is my initial amount. The R is my rate. And the T is my time. Now the only difference with this one is this N and here. Okay, so the only difference with this formula is that we have this N, and this is the number of times compounded in a year. Okay, so that's compound interest, and then continuous compound interest is A equals to P. And the very similar parts. This is my final amount. This is my initial amount. Remember, E is just a number, right? It's just like pi. Okay, then my rate, and then my time. Okay, so these are the three formulas we're going to use for word problems. Okay, so let's look at our first example here. So this one says the number of wolves in King County is decreasing at a rate of 3.5%. In Fox, if Fox currently counted 85 wolves in the area, how many will be left after Fox? Okay, so this one, we know we see decreasing here. Decreasing, we see 3.5%, and we see 85 wolves. So since we see this decreasing, that's our keyword for knowing that this is going to be exponential growth or decay. We're going to use the first one right here. So we're going to use equal to P times 1 plus or minus R to plug in our information. So we start with A. We don't know what our final is equal to 85. That's our initial. 1. We're going to subtract because we're decreasing. And then our rate as a decimal. Okay. So then we just plug this into our calculators. When you plug that into your calculator, you get A is equal to 71.13. But we're talking about wolves here. We can't have 71.13 of a wolf for wolves. So we're just going to round. Okay, there's the first one. Okay, second example. We have if Dwight deposits $4,000 into an account, paying 6% annual interest, compounding monthly, how many years will it take him to reach 16,000? Okay, so key word here is we're talking about an account and we're compounding monthly. So I know we're going to use compound. Okay, so then we take our formula and we plug all of our information here. For this one, we're trying to find years, so that's what we want to solve for is our time. We're going to start by 16,000, that's our final, equal to our initial, which is 4,000, times 1 plus our rate is 0.06. Our n, which is our amount of times that we're compounding per year, monthly, so it's going to be 12t. We're solving for 12t. Okay, so I'm going to solve for this now. So I'm going to start by dividing by 4,000. So then I get 4 is equal to 1 plus 0.06, 12, 12t. Okay, continue to plug this into your calculator. So here we get 4 is equal to 1.005 to 12t. Okay, now this looks like something we can solve. So I'm going to rewrite this as flip it. Then it makes it easier to use our log snail. So I start with the base here. So I start with a log of 1.005 is my base of 4 is equal to 12t. Divide by 12, divide by 12. So then I have log base 1.005 of 4 over 12 is equal to t. Okay, we plug this into our calculator. We get 23.16 is equal to t, or about 23 years. And there's my answer. Okay, and then for the last one, we have Baby Yoda puts $7,000 in a savings account. Okay, so I see savings account. Okay, 8% interest. Okay, that compounds continuously. Okay, there's my keyword that I'm going to use. PERT, which is our last one. Okay, so now I'm going to plug everything into this formula. So I have 49,000, which is my final, is equal to my P, my initial, 7,000, E, my rate, which is 0.08, times T. Okay, I want to solve for T. Divide by 7,000. Okay, this gives me 7 is equal to E to the 0.08 T. Okay, I'm going to flip it so I can use my log scale. Start with my base. Going from an exponential to a log. To a log. 7.08 t. Okay, divide by 0.08. Okay, and I get, remember this is just a fancy way of the natural log of 7.08 is equal to t. I plug this into my calculator. And I get 24.32. So about 24 years. And there's my answer.